I guess like uh, I'm telling, yeah, sign off. What do mean sign during the sign off? Like we have done floor plan, placement, CTS, and routing. So it should be clean. It should be followed at TCR, TRC. Sorry. Uh, it properly we did all this by following TRCs and TRVs. TRVs we give during the uh, through SDC only. Hello. Okay. Uh, we done all these stages by following properly or not. We have to follow those. We have to check those things. Sign off can be done in like PV. PV means physical verification. All the layout they will check DRCs, LVS. LVS means whatever we have given netlist as an input, it should be matched after the layout. Like after doing routing, it should be match the logic what we have provided through netlist. Okay, it should be matched with that netlist after we have created layout. That layout should be matched with the netlist. That is LVS. Okay, layout versus schematic. Okay, and another thing is timing sign off. Okay, that we say that STA, static timing analysis. Okay, uh, we have to do all these things during sign off. If one thing you have to remember here is sign off tools are only analysis tools. Okay, PNR tool is implementation tool. Okay, if they have found anything like there is a DRC, there is a timing violation. Okay, they will know how to, I mean, they will tell us how to fix, and we have to fix those violations by coming back to PNR tool, and we have to fix those violations. Okay, you have to remember this thing. Every interviewer must and should they will ask this question. Like uh, sign off tools are analysis tools, and PNR tools are implementation tools. Okay, they will analysis the design, and if there are any violations, they will report to the PNR's engineer. They have to fix. Okay, if everything is clean, then CDS2. CDS means graphical design system. Okay, we have to generate that CDS and will give that CDS to the foundry. They will manufacture the design. Okay, I hope you people understood the PNR also. Next, Rohit. So macro guidelines. To place the macros in the core area, we have to follow some guidelines. Okay, these are the major guidelines we have to follow during the macro placement in the floor plan stage. Okay, you people should uh, uh, I mean, uh, make sure that all the macros has to place only during the floor plan stage. Okay, what are the guidelines? These are the guidelines we should follow. Okay, this question also very commonly every interviewer will ask. Like macros should be placed at periphery of the core boundary. Periphery means at core boundary. We have to place those macros near to the boundary. Okay, all the macros you have to uh, uh, place these macros at the boundary only. Okay, there are some scenarios also to place other places, but those are secondary. Majorly, we place all these macros at the boundary only. Later, macro pins should be faced towards the center of the core area. Like you have one macro. It pins should be its face, face of the, like, consider the macro face wherever the pins are there, like I will draw. Consider this as a macro. Okay, here pins are having this area. Okay, macro pins are there like this. Okay, sorry for the drawing. Okay, all the pins are having this side. So this side should be placed in this direction. Like, consider outer square as a 4. Okay, this is a macro. So these pins should be faced towards the center of the core area. This is the consider as center of the core area. Should all the macro pins should be faced towards the center. Okay. Next, macro should not place at middle of the core area. If okay. What happens if I place a macro here? Okay. This is macro. This is a standard cell. So here what happens? If there is a connection between these two standard cells like this, okay, is taking more area, more, I mean, those length will be like this macro is at middle. Okay. If there is no macro, then how they will connect like this? Okay. Okay. Like this, they will connect. But there is a macro between them. Okay. Then tool what to will try to bring that net this much of forward from the macro, and will do an OT, and again will connect this standard. So we usually we say this as a roundabout routing path. Okay, these this is the major issue. This is not a simple thing to avoid. It is very issue because most of the routing tracks it will occupy macro, because uh, I think you people know each and every macro will occupy some layers from base layer to like four metal layers or five metal layers. It will block. Okay, macro will block those metal layers. Okay, due to that, tool has to do like this. So more number of routing tracks will be wasted during, I mean, here these stages. Just do this. Okay. This is the reason why we should not place at middle of the core area. Okay. Avoid not just the for a. What is not? This is also I have to talk. This is a core area. I have macros like this. Another macro. Another macro like this. These are the macros. Okay. In this area, okay, there is no, I mean, uh, there is extra area present in this particular region. So what happens here means more congestion may occur in this area because each and every macro will have more number of uh, input output pins. Okay, like some macros will have hundreds of pins, so they need more number of routing tracks. Okay, if there are if there is area here means uh, tool will try to place standard cells here. Okay, if the more number of standard cells here means they also need routing tracks. This macro also need routing tracks, and this macro also needs routing tracks. So what happens? More congestion will occur. I mean here in these places. Okay, if there are more cell density means more number of standard cells are there here in this region means power also will be an issue because uh, these macros will consume more number of more power compared to standard cells, so they need more power. If there are more standard cells in this region means our power strips should uh, uh, provide power to the macros and standard cells also at this particular region, so that will lead to IR drop issues. Okay, I hope you understand this also. Next, avoid crisscross. Crisscross means, again I will draw. There are two macros in the, okay, like this. There is a pin connection like this. Okay. So we have to avoid this type of connections. Like instead of placing like this, we have, yeah, this is the direction. Someone drawn like this. Okay, thank you guys. Uh, we have to place, we have to flip the macro like this. If you flip the macro, those pins will come like this. Okay, the direction will be like, here if you see this macro direction is like this and this macro direction is opposite to this macro. Okay, now in this diagram if you see both are in same direction, macro pins are, so it will avoid using more number of routing tracks. But this is also we have to do. Next, place talking macros near to each other, like one macro is there, one macro is there. These two are talking to each other. Okay, instead of placing like this, we have to move this macro from here to here. We have to place like this. So these macros will occupy less number of routing tracks. Okay. This point is like that. Okay. Next, maintain proper halo around the macros. What is halo? Halo means providing a blockage around the macros. Halo means like this is the macro. Guys, who is this? Please don't touch the screen. Uh, I have a macro like this. I have to provide blockage around the macro. So, so this is the halo around the macro. Who's this guy? Please don't touch the screen. Okay, this is halo. What it will do means it will try to avoid placing the standard cells in this area. Okay, in this region, tool will try to avoid placing the standard cells. Okay. Why we have to avoid placing standard cells near the macro means to save the standard cells from IR drops. Okay, if the standard cells are having near to the macros, then macro will consume more power. Then standard cells will not get required power from the stripes. Okay, that is the major issue we face if the standard cells will be, I mean, are at near to the macro. So, and that is the one reason, and another reason is, as I said, macros will have more number of input output pins. Those okay, those macros will have more number of input output pins. They need some tracks. Okay, standard cells also need some tracks. So there may be occur more congestion at those places. Okay, these are the major guidelines we should follow while placing macros. Okay, so path path. What is path? The paths which are physically exist in the design but logically inactive the functionality in the chip. Those paths are considered as false path. Uh, Rajat, are you there? Can you remove this guy from the session? Whatever. Please don't do this guy. So this is a false path example. There is two muxes in the design, and mux one output is going to both inputs of mux two. Okay, in three, in four. Y1 is going to in three and in four. And same selection line is going to store two muxes. Okay, how many paths are there in this design? Means in this circuit, this particular circuit is path one is in one y1, in three y2. Okay. Uh, Path 2 means into y1 in4 y2. Path 3 in1 y1 in4 y2. Path 4 into y1 in3 y2. So in these paths, if I give 0 as selection input, okay, path 1 will get inactive because 0 is going to both muxes. So path is like this. Okay. If I apply selection line is 1, then this path will get active. Path 1 and path 2 are getting activated in this circuit. But if you see path 1, path 3 and 4 are permanently not getting activated at any scenario because both selection lines are going to both muxes, single selection line. Okay, that will lead to make inactive path 3 and path 4. Okay, so if you leave these paths like that only, so tool what do means it will try to take timing optimization for path 3 and 4 also. Okay, to avoid that, we have to set uh, false path for those 3 and 4th path. So then tool will avoid fixing timing for those path 3 and path 4. Okay, I hope you people understood. This is a very simple concept. Please repeat I3 I4. I3 means which one? Path 3 and path 4 you people are asking. False path which are deactivate. Okay. If I mention false path for path 3 means it will avoid fixing path like in1 to I1 and I'm telling arcs like uh, it will avoid timing calculation for this path like in1 y1 in4 y2. This is one path. I will draw. Okay. Another is this path. Okay. Tool will not fix these two paths in1 y1 in4 y2 and in2 y1 in3 y2. These two paths tool will avoid to fix timing because these paths are permanently inactive in the design. Okay, so tool will avoid fixing timing analysis for these paths. Okay, there are another scenarios also. I will explain that scenario later. That is in the slide. Guys, why you people are doing like this? So, uh, see guys, why top metal layers are using for physical I mean power stripes. Top metal layer. I think you people know. We do power plant in the top metal layers only. Like if my design have 10 layers, then I use 9 and 10 or Okay. uh, or like if my design have 12 metal layers, then I use 11 and 12 for routing, power routing. Okay. For sometimes there will be like some restrictions to complete the design by using only 10 routing metal layers. Even if there are 12, they ask us to complete the design by using 10 layers only. There will be some scenarios like that also. Okay. Please guys, don't do this. I'm asking you. Please try to learn, or else please leave the session. Okay. These are the reasons. Power roads generally I mean conduct a lot of current, because uh, as you know, if from the time chip is enabled, from the time to uh, when chip will get to turn off, these routes are continuously will provide power to the standard cells. Okay. So these people are disturbed. Okay. In order to reduce the effect of IR drop, we need to make these routing less resistive. So top metal layers are thicker and less resistance. Why means this is the formula. Resistivity equals to RA by L. Uh, uh, Rho means resistivity, and R equals to resistance of the material whatever we are using. Okay. Next area. For how much area, uh, like if you consider 1 unit length area, for that particular unit length area, how much the resistance, we have to mention that resistance also for that particular material, and how much the length is. Like I have like this. Like this is a net. Okay. For this net, 100 micron. This net length is 100 micron. So for each and every uh, uh, unit length area, how much is the resistance? Okay, we have to mention all these things in this formula. We have to substitute. Next, this helps to reduce IR. Yeah, yeah, guys. So if you are using top metal layers, power rods will have less resistance. And another thing is, for power rods, we will maintain more width compared to normal signal and clock nets, because the effect of EM is very much in power rods. Okay, to avoid that, we have to provide more width for the power rods. Okay. So to remove that guy, I don't have permission. Okay. I'm unable to remove that guy. Sorry for that, guys. Okay. So this is the formula for the resistivity. Okay. Uh, Next, as I said, we maintain more width for the power rods. If you are using those power rods, roads middle of the metal layers or bottom metal layer, that will lead to uh, uh, occupy more routing tracks. So we are wasting more routing tracks if we are designing that if we are using that bottom layers for the power roads, means that will lead to lose more power roads, I mean tracks or routing tracks. Okay, these guys are the congestion. What is congestion? I will try and explain. I have this metal layer. Okay, let's say M1 or also M4, four metal layer. This is it. Okay. And tool what do means will divide entire uh, metal layer into multiple G cells. G cell means global cell. Okay, will divide like this. Multiple G cells.
Sir, how many slides are left? Uh, how much time it will take to complete?
Yeah, I think there are more slides are there.
Okay, can we do it tomorrow? Like you want to do it completely today itself?
Yeah, I'm okay. Like you can ask students.
Today itself.
If the students are willing to
Okay, you
listen,
can
I will.
complete it today itself. Okay, fine.
Okay.
If anyone if any like problem is there, just rejoin the same link because we have the 40 minutes limits, right? So rejoin the same link if the meeting will drop, right? Rejoin the same link.
Okay.
Okay, fine. Thank you.
Because tool. Yeah, right, right. So tool divide like this. Okay. There will be metal tracks, routing tracks. Okay. Have like this metal tracks. Let's say each G cell have 10 metal tracks. I draw separately for so consider this single particular G cell. Okay, this G cell will have 10 tracks. Please, guys, do this. I'm asking. Okay, like this. Okay, in this particular region, I have 12 nets to route, but there are only 10 available routing tracks are there. So then tool what will do means will do routing. Don't do this. Can you remove this guy?
What is the name of this person? What is the name of this person?
Hey,
Hey, Hey is not there. Hey,
then how
Xiaomi,
this
Xiaomi.
guy?
Xiaomi.
Xiaomi.
Okay. No. Xiaomi is not there. Hey is not there.
Xiaomi. Here have spoken name.
Xiaomi is not. Hey is not here. Yeah. Okay. Yeah. You can continue. Just avoid the person. Actually, these are the spammers from Big Coaching Institute. That is the only thing,
Okay.
right? Yeah. Just
Okay.
ignore completely. Not just focus on this.
Okay. So
This
guys,
meeting will go over in 1 minute. So just rejoin the same link. After dropping the okay.
so from this